Kia ora, here's question 2E from this year's complex numbers paper. So I think this question is quite straightforward. It's just got one funny little thing at the end, which you don't want to get confused by on the way through. So it's a locus problem, and we're told that we've got the locus of a complex number is given to us by this. And then we're told that the complex number u equals 3 plus di lies on this locus. So first we just have to find the equation of that locus, and then we also have to find u. So if you think about it, we're going to get some shape. And I'm going to do one that's wrong, right? So it's not going to be an ellipse on its side like this. That would be kind of yucky. Let me draw a slightly better ellipse. If you're watching this going, what's an ellipse? Don't worry. I'm just giving you an example of a locus, which is a set of x's and y's that satisfy this condition. Now, to say that u equals 3 plus di lies on this locus means that the x value is equal to 3. So what this question is really asking is to say, well, if x is equal to 3, then tell me what the y value is. So d is the y coordinate on that locus. And if you kind of keep sight of that the whole way through the problem, I think conceptually this question is not difficult at all if you're used to doing locus problems. Okay, so the first thing we're going to do is, as usual, let z equal x plus iy and work from there. So there is quite a bit of algebra. The first stuff is lots of expanding, and then, as we often find, we need to complete the square on both the x stuff and the y stuff. Right, so I'm going to do all of the steps in this. If this video is a bit too slow for you, then I don't know, just don't watch it or put it on double speed. So we'll start like this. And now we're going to substitute in next we're going to group our real and imaginary parts. So we're going to have in brackets x minus 1 plus I times y minus 7 is equal to 2 times the modulus of x minus 4 plus I times y minus 4. It's worth checking as you go that you haven't made any copying errors, because you know it's going to really muck things up as you have. So pause the video now and try and go right from here on this question. Okay, so then my next step is to apply my definition of a modulus, which is just Pythagoras. So we've got x minus 1 squared minus y minus 7 squared, all square rooted. And then here we've got 2 times this. Now, the reason that I put this line in instead of skipping straight to the squaring is that a really common mistake is not to square that 2. So it's fine if you did jump straight to here, but hopefully you remembered that that needs to be squared as well as all the other stuff. So now we have x minus 1 squared plus y minus 7 squared is equal to 4 times all of this. And because this is a 4 and this is not, I'm going to have to do quite a bit of expanding work and then collecting up like terms. So I'm going to start on the right-hand side and expand this. And I get 4 times x squared minus 8x plus 16 plus y squared minus 8y plus 16. Let's clean that up. I get 4x squared minus 32x. Here I've got 32. 32 fours gives me 128. I'll pop down my y squareds first though. So we've got 4y squareds minus 32y plus my 32 times 4, which is 128. Now on the left-hand side, we have something a bit easier. We have x squared minus 2x plus y squared minus 14y. I've got plus 1 from here and plus 49 from here, which gives me plus 50. Right, getting everything onto one side, we have 0 is equal to 3x squared. I'm adding on 2x. I get plus, oh, whoops. Minus 30x plus 3y squared minus 18y plus 78. I'm going to divide all of that through by 3. and I get x squared minus 10x plus y squared minus 6y plus 26. Now we're going to complete the square twice over to get my locus. So we're going to put a little box around this and a little box around this and take out the extra stuff. Right, x minus 5 squared minus 25 plus y minus 3 squared minus 9 plus 26. If you're not confident with completing the square, probably a bit late now, but if you need it for next year at uni, go watch my video on how to complete the square, because you need it for life. Right, this is minus 34 plus 26 gives me minus 8. So we get this very cute little circle locus. And you should be feeling pretty happy because lots of things divided out, right? So it feels like you're on the right track. Now the last part of the question, so that's the locus. We put a little box around that. That's good. And then the very last bit is to say, find the complex number or numbers u. So here it is, u equals 3 plus di. So u equals 3 plus di. So when x is equal to 3, we get 8 is equal to 3 minus 5 squared, just substituting in here, plus y minus 3 squared. So 8 is equal to 4 plus y minus 3 squared. 4 is equal to y minus 3 squared. Now, I could quadratic formula that, but that seems like a waste of time. I can just square root both sides. So plus or minus 2 gives me y minus 3. So y is equal to 3 plus or minus 2, which is 1 or 5. So my complex number u is equal to 3 plus I, or 3 plus 5i. So there we go. That's the final answer for that one. Thanks for watching. Hopefully there's no mistakes. I'm sure someone is going to let me know if there are, because I have just seen a comment come up about the last video I made. So please let me know if anything is up with that one. I'm just trying to think, actually, before we finish, if we should say, oh, we just have to give the Cartesian equation of the locus. You know, it's sort of, whenever I do a locus question, I do like to actually say what shape we've found. So I'm just going to write that in. I'm pretty sure you won't need this for excellence, but there you go. So it's a circle with a center at 5, 3 and a radius of root 8 or 2 root 2. Okay, there you go. I'll do 1e shortly. Thanks.